Hi everyone, our topic for today is Smart Learning on the Pharmacology of Aminoglycoside, Macrolide and Lincosamide. These three antibiotics are also known as protein synthesis inhibitor. For your information, proteins are synthesized according to the instructions contained in the DNA nucleotide sequence. It includes the process of transcription and translation. The antibiotics above are able to inhibit the bacterial protein synthesis. Now, we will show you how to learn and memorize this topic effectively in a smart way. Let's get started. Okay, first of all, we would like to look into their antibacterial spectrum. For the first one, macrolides. They are more effective against gram-positive organisms, and they are bacteriostatic, which delay or slow down the bacterial growth. Next is the aminoglycosides. They are widely used against aerobic gram-negative organisms, and they are bactericidal, which means they kill the bacteria. As for the lincosamides, their spectrums are similar to macrolides, where they are effective against gram-positive organisms and they are bacteriostatic. Now, we look at the mechanism of action of the antibiotics. First, we talk about the aminoglycoside. This antibiotic binds to the 30S ribosomal subunit. Basically, it has two types of mechanisms. First, it leads to the misreading of the mRNA, which results in the wrong amino acid being translated. The second one is by blocking the translation, which prevents the transferring of tRNA from A site to P site. This is the overview of the mechanism of action where the aminoglycoside binds to the 30S ribosomal subunit. First, we will look at the normal mechanism of translation of the amino acid. When the codon in the mRNA is being translated, the amino acid synthesized by the tRNA in P site is transferred to the tRNA at A site. Then, when the ribosome moves forward, the tRNA in the E is being eliminated and the tRNA in A site moves to P. When the aminoglycoside binds to the 30S ribosomal subunits, it causes the misreading of codon. The transferring of the amino acid still occurs, but this results in the translation of wrong amino acid and so the wrong polypeptide. Second is the prevention of elongation of polypeptide. This is the normal mechanism of translation of amino acid without the presence of the aminoglycoside. When the aminoglycoside binds to the 30S ribosomal subunits, the tRNA in the A site is being blocked to move to P site. Hence, the amino acid in the tRNA is unable to be transferred and thus prevent the elongation of the polypeptide. Next, we will look at the mechanism of action of macrolide. Macrolide binds to 50S ribosomal subunits. There are also two types of mechanisms in the macrolide. The first one is preventing the transfer of tRNA from A site to P site, which inhibit the translocation of peptidyl tRNA. The second one is preventing the formation of peptide bond, which will inhibit the elongation of protein. Now, we will show you the mechanism of action of the macrolide in the analog. Let's mix out the character now. First, the girl named Alice represents the tRNA in A site. The guy named Patrick is the tRNA in P site. The road sign with a number 50 is representing the 50S ribosome subunit, while the love shapes represents the amino acid and the road with all the alphabets on it represents the mRNA with their codons. And of course, the main character, which is the macrolide, erythromycin, is represented by both Erica and Eric. And lastly, this guy represents another new tRNA. So, let's start with the first mechanism, inhibition of translocation. Patrick is in love with Alice. He gives his love to her. This represents the amino acid in P site is transferred to the tRNA in A site. Then here comes Erica, which represents the erythromycin. She kicks away Alice from getting closer to Patrick. Another guy who comes to Erica will also be kicked away by her. This means that the presence of erythromycin will inhibit the tRNA to transfer from A site to P site, and therefore inhibit the translocation. The second mechanism is preventing the elongation of polypeptide. The same situation occurs between Patrick and Alice, but this time here comes Eric. The presence of Eric makes Alice attracted to him. So, Patrick is rejected, and the love between them is no longer exists. This means that with the presence of erythromycin, it will inhibit the formation of peptide bond between amino acids. Therefore, the elongation of polypeptide is inhibited. For lincosamide, it is similar as the macrolide, which inhibit the translocation of peptidyl tRNA and inhibit the elongation of protein.
Mechanism of resistance of this drug. There are a few factors that contribute to aminoglycoside resistance. First, the prevention of porine penetration. Second, reduced ribosome affinity to the drugs. And lastly, alteration of the drug by microbial enzymes. Due to the alteration of the protein, the drug is prevented from entering the cell. The mechanism of resistance of macrolide is similar to lincosamide. First, the efflux of drug by active FAR mechanism. Second, the action of methylase enzyme that causes ribosomal modification. Third, the hydrolysis of the drug by esterase. And lastly, the alteration of 50S ribosome by chromosomal mutation. From the movement, it is noted that the drug enters the intracellular fluid. However, it then rapidly effluxes from the cell.
Now, we learn about the pharmacokinetics of this drug in a different way. Let's start off with the aminoglycoside.
My name is aminoglycoside. I'm an antibiotic. This is my friend Ivy. Every time he brings me to the place that I always go, that is human body. Once I enter the body, I would love to travel all over the places. I don't like to meet the unfriendly guy brain. There is a barrier called blood-brain barrier, BBB, which prevents me to enter his place. But I like to stay at the place of another guy here. He is friendlier. Then I walk all over the places. Finally, I stop at Kidney's place. Then I will exit from here by glomerular filtration. However, I might also bring some bad luck to the human body. I can cause toxicity to the kidney, which is known as nephrotoxicity. Not only this, because I like to stay at Ear's place, so maybe I will bring ototoxicity to him too. Oh yeah, I forgot to tell you, I have a best partner. She is penicillin. When I meet her, we can give therapeutic synergism and a better effect to the human body. Yahoo!
Hello everyone, my name is erythromycin. I am one of the macrolide. I can enter to human body by myself through their mouth. That means I enter to their body orally. I diffuse into the body fluids. First, I will meet a guy called liver. I like to stay at his place and I will be metabolized there. I will walk through their gastrointestinal tract, GIT. Walking along this tract, I meet stomach. At this place, there are many fierce people. They are called gastric acid. They tend to digest me. Luckily, I have a coat to protect me. Whee! After that, I meet small intestine and I will be absorbed there. However, I prefer to get alone into the human body. If there is another else goes along with me, they will slow down my absorption in the small intestine. One more thing to tell you, as what happened to aminoglycoside, we also not allowed to enter brain's place due to the barrier. Lastly, I exit this body in the form of bile. However, I do bring adverse effect to human. Since I always pass through the GIT, they can easily get GIT effects such as anorexia, nausea, vomiting, and diarrhea. Other than that, I can bring some problem like liver toxicity. Hi, I'm lincosamide. Actually, I have many similarities with macrolides. I enter the human body by myself too, that is, by orally. Yeah, similar to erythromycin, by orally. I will pass through GI tract, meet the guys called stomach and small intestine. I will also be metabolized in the liver. Besides, sometimes my friend Ivy will bring me into the body. I will diffuse into the body fluid and travel to all tissues in the body. Travel, travel, travel. It's so fun travel all over the places. But I can't cross blood-brain barrier. And finally, I will stop at kidney and exit from there. I do bring adverse effect to the human too, such as GIT effect and colon inflammation.
Therapeutic use of this antibiotic. Aminoglycoside is used to treat Pseudomonas aeruginosa and Enterobacteriaceae species infection. Next, for macrolide, it is used to treat diphtheria, mycobacterial infection, and chlamydial infection. Lastly, for lincosamide, it is used to treat the Staphylococcal conjunctivitis and penicillin-resistant staphylococci infection.
In conclusion, aminoglycoside inhibits 30S ribosome subunits, whereas both macrolide and lincosamide act on 50S ribosome subunits. Three of them share the similarities by blocking the translation process and prevent the elongation of the polypeptide chain. So, do you have a clearer vision on protein synthesis inhibitor now? Thanks for watching the video. Bye!